All right, guys, in this video, I am going to show us how we go about solving quadratic trinomials using the quadratic formula minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I will answer questions 1, 3, and 5, and then I will ask you to try questions 2, 4, and 6 yourself. Okay, so starting with question number 1. Question 1, I have a quadratic in n. It is 3n squared minus 5n minus 8 is equal to 0. Notice that my quadratic is already in the form ax squared plus bx plus c equals 0, so it's already in that form that I want. It means now that I can just read off, as it were, the coefficients on my on each term. So my a is the coefficient of my square term, that's n squared, so that's 3. My coefficient on my n term, b, is negative 5, and c, that's my constant at the end, that is negative 8. All right, so once you've correctly identified the coefficients, really, in many ways, that's the hardest bit done. Now, all you have to do is just plug them into the formula, and you will find the solutions to this quadratic equation. All right, so minus b will be minus negative 5 plus or minus the square root of b squared minus 4ac is minus 5 squared minus 4 times 3 times negative 8, and all of that over 2a, which is 2 times 3. All right, minus 5 is going to give me plus 5, plus or minus, again, we know that a quadratic will have 2 factors and then potentially 2 solutions, as many as 2 solutions, and the 2 solutions are going to come from that plus minus at the end, as we will see. So 5 plus or minus the square root of minus 5 squared is 25. I have minus 4 times 3 times negative 8, so that minus times the negative 8, those two minuses will eat each other up. That'll give me a plus. 4 times 3 is 12. 8 times 12 is 96. So I have 96 all over 6. And so that is 5 plus or minus the square root of 25 plus 96 is 121 all over 6. The square root of 121 is 11. And so I have 5 plus or minus 11 over 6. And so I have 2 solutions. Either n is equal to 5 plus 11 over 6, or n is equal to 5 minus 11 over 6. These are my 2 solutions. 5 plus 11 is 16. 16 over 6 is 8 over 3. 16 over 6 divided by 2. And 5 minus 11 is negative 6. So I have n equals negative 6 in my numerator, 6 in my denominator, that's negative 1. So my 2 solutions are n equals 8 over 3 or n equals negative 1. Those are the 2 values of n that will satisfy my original equation, 3n squared minus 5n minus 8 equals 0. All right, so that's the first one. That's using the quadratic formula. All right, let's move on. I think I said I'll do number 3 next. So number 3 is 10x squared minus 9x. 10x squared minus 9x plus 6 equals 0. All right, so again, a quadratic trinomial. We're going to use minus b plus or minus. Again, note straight off, it's very important that I'm in the form ax squared plus bx plus c equals 0. So my values for a, b, and c can now be just, as it were, read off from my equation. So my a is my coefficient of my x squared term, that's 10. My b is my coefficient of my x term, that's negative 9. And my c is my constant, that is 6. Plugging it in, minus b becomes, well, it's minus 9, so that's plus 9. Plus or minus the square root of b squared is going to be negative 9 squared, that's 81, negative 9 squared, b squared, minus 4ac is 4 times 10 times 6, and that all over 2a, which is going to be 20. 2 times 10, 2a, 2 times 10 is 20. And so I have 9 plus or minus the square root of 81. 4 times 10, well, 4 times 6 is 24, times 10 is 240. So I have 81 minus 240 minus 240 is negative 159. And again, that all over 20. And I stop here because I have a negative number underneath my square root sign. There are no real solutions to the square root of negative 159, and so I cannot go any further. That means that this quadratic trinomial, 10x squared minus 9x plus 6 equals 0, has no real solutions, and that's our answer, as it were. There are no real solutions to that quadratic equation. And again, the reason I know that is because I have a negative number underneath my square root sign. That part underneath the square root sign, that b squared minus 4ac, we call that the discriminant. And when the discriminant is negative, it means that there are no real solutions. And so that's it. That's as far as we can go. There's no point going any further. All right, finally, last one. I will take question number 5. Question number 5. Just go up to remind myself. 6x squared minus 12x plus 1. 6x squared minus 12x plus 1 equals 0. All right. So again, can't state enough. It's very important that you notice straight away that you're in the form ax squared plus bx plus c, and if you're not, that you make sure that you put your equation in that form to start. All right, so my a then is 6, my b is negative 12, and my c is positive 1. All right, plugging them into minus b, I will get minus negative 12, that's plus 12, plus or minus the square root of b squared is minus 12 squared, that's 144, positive of course, minus 4 times 6 times 1. 4ac is 4 times 6 times 1, and that all over 2a, that's 2 times 6, that's 12. And so I have 12 plus or minus the square root of 4 times 6 is 24. So I have a 144 minus 24. So that is the square root of 120. I have a positive value underneath my square root sign this time, so I'm fine. I should have real solutions. In fact, I will have real solutions. The square root of 120 is the square root of 4 times 30. 4 times 30 is 120, and 4 itself is a square root, so is a perfect square. So I have the square root of 4 times 30. Maybe just write that out, which is the square root of 4 times the square root of 30, all over 12. And the square root of 4 is 2. And so I have 12 plus or minus 2 root 30 over 12. And so my solutions, it's x, the variable we're using. X is equal to 12 plus 2 root 30 all over 12. And x is equal to 12 minus 2 root 30. And that all over 12. All right, simplifying over here. I have a 12 over 12, that's 1. I have a plus. 2 over 12 is the same as 1 over 6. So that is 1 root 30 over 6, or root 30 over 6. So I have 1 plus root 30 over 6. And over here I have x equals, again, 12 over 12 is 1, minus 2 over 12 is 1 over 6, so that is root 30 over 6 again, but this time negative root 30 over 6. And those are my two solutions. Maybe I'll just leave them like that. 1 plus root 30 over 6, and x equals 1 minus root 30 over 6. Get out your calculator, you can work out what that is as a decimal if you want, but I prefer to just leave it in that surd form. And that's it. That's how we solve those kinds of problems. The quadratic formula is very important. It comes up over and over and over again in Algebra 2 and pre-calculus. And so being very familiar with it, knowing it off by heart, minus b plus or minus, knowing that formula by heart, and knowing how to rearrange a quadratic equation if needed to be in that form ax squared plus bx plus c equals 0, so that you can correctly identify what your values for a, b, and c are, putting them in, and then just, like I say, working through the algebra to get your solution. It's something that is very, very important that you're as a skill for the high school math student. And so, like I say, I will leave you to do then questions 2, 4, and 6. Notice with questions 4 and 6, it's quadratic, but they're both quadratic binomials. It's only 2 terms. And in both cases, you'll notice that it is the second term that's missing. So you have a square term and you have a constant term, but that middle term is missing. And similarly with question number 6, there's an n squared and then there's a negative 11, but that middle term with just n is missing. That's okay. What that means though is that your b is 0. So just proceed, maybe use the quadratic formula and just have b equal to 0. Your a will be, in question 4, your a will be 1, your c will be negative 9. You can work through it and you will come up with 2 solutions that way too. All right, thanks a lot. Hope this was helpful.